Hey, what up? Today is the second day for our series where we build Snake with ECS principles. ECS stands for Entity Component System and is a widely used pattern in developing games. What I'm trying to achieve with this project is actually figure out what are the challenges of creating a simple game with ECS. Of course, it might be overkill to make Snake, which is one of the simplest, the most simple example out there of a game, but I think it's a good example. And last time we were trying to see how to communicate between services. Communication between services is very important because, let's see, we have to tell the Snake that we want it to be moved. Then the grid system has to tell the Snake, hey, you can move or you can't move, or you're gonna hit the fruit or you're not gonna hit the fruit. So let's see a simple diagram of how we want this system to work. So right now we have a grid system. Grid system. Let's see. Keyboard system. And of course a rendering system. Don't care about rendering right now. And this is the Snake entity. Snake entity. Okay, so the keyboard system right now tells one of the components of the Snake, which is position on grid, that actually updates the position on grid, which I believe is incorrect. Rather than doing this, no, actually updates the position on grid, the future tile and then grid system, so this is 1, and then the grid system takes the future position, takes this future position and decides to move from future to current position. But I think this flow might be wrong. So basically the key system queues a possible future position and then the grid system takes this what if let's figure out another way. So the key system actually I think this is correct. So the key system there would be another solution where it would be like something like a snake system. But it doesn't make sense to tie a system to an entity where this guy receives data from this guy and then goes here, and then this this has to come back with the data so I can decide what to do with the snake. What if the key system queues up the position, right? Then the grid system computes the next position, but in the same time sends sends an event to either the snake entity, either another system. And this is the question here. Should the grid system doesn't care about the rest of the events, right? Grid system only cares about the grid system, and then we need a separate system to deal with the snake, because the snake has its own transformations, and this is why I believe should have a system. Just a second, take a Okay. Be right back. All right. So it's clear to me that the systems need to communicate between them. And the system need to be able to subscribe to one another. That's the most interesting part. Let's see what the internet says. So ECS, how do systems interact? Ideally they don't interact, not in any direct sense. The systems in an ESC all have access to a central database where they can fetch entities, components. They don't talk directly to each other, they talk to the database. Okay, so I think we saw this yesterday as well. So the components, actually, give me this picture because I need it. So components talk to the system talks back to the component. This is something that is happening right now. So this scheme here, where the system processes entities and then talks back to the component, already happens. We don't have any communication between these two. We just have an hierarchy. Like, first we process position, keyboard, then we process the position, then we render it. And this is what worries me actually, is because normally in any application at some point you need a feedback between the systems, and there's no feedback at the moment. I don't know why. We'll probably see down the line. So dependencies flow towards raw data, not abstractions. The dependencies in an ECS do not flow towards functions, not even abstract functionality. They all flow towards raw data, which might sound like an epic violation of many accepted software engineering principles. And in my opinion it is, but yields something easier to maintain. For some cases. It will not be our case, by the way. Because the snake is in ECS made with ECS is an overkill by any margin. Maybe some software engineering principles are wrong or at least not applicable for all scenarios. There are many situations where it's easier to achieve data stability than interface design stability. As a basic example, it's much easier to reason about what data fields a raw matrix component should have once and for all, and keep that stable and changing for years to come. It's much harder to figure out what functions an abstract I matrix interface should provide once and for all and keep that perfectly stable and changing for years. Yeah. Okay. So in appropriate cases, when your dependencies flow towards data instead of abstract functionality, your code base will find fewer and fewer and fewer reasons to have to face central design changes. Yes, that's right. With cascading effects and potentially big parts having to be rewritten. To direct dependencies towards data, in that case, is directing them towards stability. It's worth asking yourself as a developer whether the tendency in your system is for developers to add, change, or remove functionality, or add, change, and remove data from components. If systems start to depend on each other a lot, that's directing dependencies away from data and towards functionality. I agree with that. And many of the maintenance benefits and the ability to reason about the correctness of your engine and easily keep it stable at the design level will be lost. Of course, a pragmatic solution might sometimes call for a system calling a function in another every once in a while, but you should generally seek to keep that a bare minimum. Instead of talking directly to each other, you can have system modify and attach components to entity in a way such that other system can pick up those changes. This is actually what I believe to be the core philosophy, if you may, of the ECS. So instead of telling another system, hey, I changed this data, you change the component. The components actually attached to an entity, and at the next iteration, the systems that deal with those particular entities that contains those new components will react. This is very important, actually. Very important. System interaction. The rendering system must know the data from the positional component of an entity in order to draw it to correct position and so on. Then it can grab from the ECS database, looping to entities with renderable and position components. I already have this. Just as the physics systems before it might loop through entities with position components and modify their position. For each entity with the components I'm interested in, do something with. Yeah, correct. And you have to start thinking about doing things in passes. Often multiple passes, even if the intuitive solution is to do everything in one pass. This was the problem yesterday, where I tried to optimize and I noticed that you need multiple passes. For example, it might come more intuitive to loop through all your game entities and apply physics and respond to input and process AI and render them all in one go. Yes, absolutely. That can minimize the amount of loops you have and also require less state. True. However, the ECS tackles this difficulty with multiple simpler passes and sometimes slightly more intermediary state to use from one pass to the next, but as a trade-off it leads to a much easier system to maintain and one which is easier to change and potentially parallelize and vectorize. I agree with that. The problem here that I'm having is that JavaScript is single-threaded. So, however you want to look at it, it will not be performant, at least until I introduce cache. As Yuri mentioned, it could also make things harder to parallelize, at least across systems in an inner system way, but could make things easier to parallelize in an intra-system way, because it's easier to reason about the correctness of a parallel loop without locking if it's, say, making less state changes on the way, and the code involved in the pass is much simpler. In my blunt opinion, it's often not worth multithreading the systems themselves so much as the loops they are performing inside for the most performance critical systems. Okay. So apparently the GPUs aren't so good at doing complex things with each iteration. So they often excel instead at doing simple things per iteration that add up to a complex task after repeatedly running through the same data with multiple simpler passes. Yeah, for each of these components apply physics. For each of these components apply rendering. Yeah, this is interesting. You can remove at some point one of the systems, like you can remove the physics, and that doesn't mean the game will not work. This is fantastic. Event-driven programming. Event can be a bit awkward with ECS, but one straightforward way to solve that is to have event queue components. A system can push events to those queue components. Ah, okay, that makes sense. Not a system to pop and process in the fair fashion without the first system directly calling function in a second. Again, the bug of it should not be system to system, but system ECS, system to component. System and components are not restricted to one-to-one relationship, though this is a desired trait that allows parallel processing without requiring synchronization. Generally, a system can operate on any number of components attached to an entity. For example, consider the following typical setup. Components: mass, acceleration, velocity, model, systems, physics, rendering. Alright. interesting question. However, if the rendering system has to combine position component and model component of an entity from two separate lists, there's no such thing of two separate lists, in my opinion. Because you just mark that components as renderable. Okay. The question was, I should have read this the first time. I'm studying entity component system architecture philosophy. As I read about it, a typical system has entities which merely ID tags, which have a number of components which contain data on various aspects of an entity that that component is responsible for. Systems which update relevant components of every entity, say a rendering system update rendering, draws a picture that is storing the data of that component, positional, a movement. This statement follows from this article, which in my opinion tried to be the most clear and pure in statement, but the author did not explain how the interaction between systems should be realized. For example, the rendering system must know the data from positional system component of an entity. Okay, so I think I already I've already responded to some of my questions. I just need to start programming here. So let's see, grid system. Grid system. How much should grid system know? In other words, what are we going to do? I think this is more like the movement system. I don't know why I named it grid, but it's related to grid, whatever. So what do we do in this case? Because we need to tell how much how much from the game, the actual game implementation, do we leak into the grid system? I would say I would treat this differently. So the movement system needs to know. God damn, not again. I'm getting spam from the same guy. Okay. Obviously the grid system knows which tile is which. But then you want to notify no, you don't want to notify. We said we'll communicate through entities, right? But who knows the specificities of what should happen next? Let's put it all here. So, if it's a snake grow tile, then we need to create a new snake tile in the place of the fruit. Okay, this is first step. Add the new snake tile to the snake entity. Because then this needs to be rendered. Okay, snake entity. So this is for the snake entity, right? I'm getting spammed. Okay, this is starting to make sense here. What's not starting to make sense is the way I handle the tiles. So I believe the snake should own the velocity and the keyboard, and should also own the position of the snake tiles. And the position on grid. Should always be the first position of this guy, so we have const first snake tile, snake head, snake get component, which is snake tiles, properties tiles 0. So I get snake head of 0 of properties It's actually a snake tile here. Snake head. It's the tile of the snake head. And we have an issue with the rendering. Let's see what we did here. Render rectangle. But if the snake is never renderable and it doesn't have a position on grid, can't be moved, right? And this is why the keyboard should only be applied for someone who has so it's basically this is a keyboard control system for a snake. Right, for a snake, right. So if let's do this. Snake tiles. What if we have a component called isSnake? We don't need any properties on it. So if it's a snake, we have this. Else we have this kind of movement. Movement compatible with a tile with an entity representing a single tile. Movement compatible with a snake entity. Okay. Where is the same principle? But this time starting to make sense. Is snake head? Yes. Huh. Might be an overkill to have a snake head, but let's see. Snake tiles, entity get component snake tiles. Is snake tiles 0, and then on a snake tile get snake head tile position get component position on grid. Snake tile is tile 0, and then snake tile where's snake tile? Oh, this is incorrect. It imported from this is a component. No, this is an entity. And then this is correct. And we have snake tile position. Bum bum bum. Because we have to move the head to the next position. Right? The speed is owned by the snake. Then the grid system should only move the tile. Grid system position. Okay, but the snake itself as a position on grid. Okay. What a mess. No, all entities on grid. All the entities on grid. Okay, now the head moves, but we also have tail. So let's say this is snake tile 1, snake tile 2, $110. Okay, and if I go, the tail has to follow. That's the rule. And you see we're at the same problem. Like we already told the head to follow, and now we go to the grid system. And now the grid system says, do you have a component is snake? Is snake. Great, so if the tile is blocked, if the snake has to move, snake entity just needs to move. And the tail will follow. Sounds like a song. this is not good. Nope, here I have to do the swap thing. Do the tail to head swap. Oops. So I have snake tiles. Snake tiles array. And I do it like in the DOM game, where I do a body unshift. Now when the snakes move, you just pop the end and unshift it. Okay, so when it moves, I do the tail delay. It's so I do pop and then unshift. Wait. So I do a pop. Actually, the problem is that I will never be able to move the snake. Because the snake doesn't have a position on grid. So I need to do the following. Treat the snake separately. And care about this later. So snake entity, if it's a snake, do this and that, else something different. Great. So entity snake tile. So we just popped This is wrong. Now I get it. I get it why it's wrong. Is this only dictates the direction. It shouldn't have anything to do with stuff like tiles, whatever crap. This only tells you, okay, I'm going that direction. I'm going that direction. Okay. Just gotta write this down. Okay, direction, I need this one. Component, direction, ds. want to avoid a circular dependency here. I'm just gonna put it there. Okay, grid. I don't need this. I don't need the grid. I don't need key map. I'm gonna write this down here. Okay, so this only dictates the direction. And then from here we have a direction. So if we only render or we only update the entities with a position on grid, and a direction. I get it. Vector 1, vector 2. Right. Now, the grid systems does the following. It says, hey, you're a snake. Bam. And snake, no, an entity get component. Actually, it doesn't matter. I wanted for it to check if the direction is different than none. Maybe check that later. Get the snake tiles. Pop the first. Swap them. What the hell? Getting messages at this hour. Okay, so it does the thing where I move the last I just swap them. And then I only need to update the tile. This sounds easy. So now this becomes tail become the head. Position on grid. snake new head. Position. Okay. The snake is an entity, and now the question is whether or not it should exist on the grid. No, it shouldn't. Then we have const snake old head, snake tiles, properties tiles 0, right? So the snake new head, const snake old head was snake old head get component position on grid. So we have snake new head, position, properties tile, head we just need to do a swap. Then this one gets the old, and this one gets the new. End of discussion, right? I get it. Okay. Because there's no denying that we're just moving forward, and this is a movement without taking into account that it will hit something. Right. And then it will iterate over the body but if there's no direction, don't do anything. Okay, nothing is happening because we haven't moved the like, because we have to compute the future tile by direction. So I think it's healthier for everyone to have something like if direction is none, then just don't do anything. If direction is none, return false. Right, so if future type compute type a direction, how did I do it here? Compute feature type from direction. Okay, so I need the entity. Position. But the future position is snake hole tail. Actually, I did a very stupid thing here. Jesus Christ. So I need a feature tile. This is absolutely clear that I need the feature tile. So it's private compute entity snake tiles. I need the snake called head as an entity. And then I need this. see, I could reduce greatly snake old head tile. I need velocity. Let's say it's 1. So we got the future tile. And a future tile. Actually, let's not add this right now. Snake new head. snake old head. This is like the current head. Actually, it's better like this. Current. Head tile. Okay, the feature tile. It becomes the head. And snake new head. We do a pop from the end, we do an unshift. Snake new head position. Okay, future tile. Wait, what? Direction is 0, unfortunately. Okay, and breakpoint. Now here. Actually here. We get no direction from the keyboard. Keepers. It looks like the snake. Yeah, because it's position and direction and position on grid. But I want everything with a direction to be taken into account by that's interesting. That's an interesting contradiction. Because the snake doesn't have a position on grid per se. Do you know what I'm saying? What if I do this? Then it will miss on that one. I could add a dummy position on grid, just like this position on grid, tile 0, and be like 3 snake. Boom. Oh. What if I add another tile? Snake 3 and tile 3. Wait. We go by 80, right? So it's 30. 110, 90. What if I go 30? take a call. Okay, I'm back from taking a call. Okay. Okay, so we have the basic movement of the snake. If we want, we can make it much bigger. Let's see if we have it like my brain is malfunctioning at this hour. So we have a basic snake implemented, but without collision detection and without all the checks that the grid system is in charge of, right? What I like about this is that now I have the possibility of adding movement to whatever I want. That's very interesting, actually, because I can have a keyboard control system and I can have the same code that is here in a movement control system, and I can now switch an entity, like say this apple or this obstacle here. I can make them move individually. That's actually amazing to see. That's amazing. Now let's recap a little bit. Why did we need inside the grid system a condition specially for the snake? Because this might be an anti-pattern of some sort, although the grid system, when it iterates through the entities, it should be able to deal with each entity if it has a movement speciality. And I think this can be extracted in a different method. So we could do here a detection, an if else. Yeah. All in all, I'm satisfied with this so far. I think I'm starting to see what the direction is with all this. I'm starting to see the benefits of having entities just as mere containers. And each system, the way they deal with the entities, this is something that I think each system needs to address. Like, let's say if you have a snake, you have a hero, you have a complex entity, you deal with it inside that system, right? And events like, hey, you hit a wall, need to be broadcasted back to the entity, actually back to the component, back to the entity which holds a component, like, hey, you're dead, or hey, you lost life, or you have to lose life, you take a hit. And then other systems process this and say, hey, how many entities took a hit? It's this one. Let me erase or do whatever. So if we keep this bubbling, if we keep this pattern where the system doesn't directly communicate to another system, but instead queries the database with entities. This is the database with the entities, and then gets back to the component, to the entity itself, and updates a component. It can update a component like, okay, you took the hit, health is now -50. I'm thinking that the system also can update the entity itself to add or remove components. Like, you don't have a sword, you lost your shield. And I think this is starting to make sense right now. In the next episode, we're gonna develop the interactions with the other entities. So we're gonna develop the interaction with the hard surfaces, the boundaries of the map, and the fruits. And then we're gonna see how to broadcast events, because I believe, let's say the snake encounters an apple. That means the system, the grid system, which let's say is this one, grid system, will add a new score will increment the score on the entity. That's the question actually, because if you are in the grid shouldn't care about that. Grid should just say you're stuck. No, it should say you hit something. And then the other system, let's say like the scoring system, picks up the entity, picks up the component score and says, oh, okay, I gotta write this score down. Bam. Do the math, do the everything you have to do, update the, maybe send it to the UI. And this is something that I don't quite understand so far. So if you say always update the components, always update the components. But wait, now I get it. Actually, the screen itself is a component. Holy crap. We'll figure out next time.